This is a quick review of what is OpenGL Shader, and of course the highlight here is the program that runs on the graphics processing unit. So all this code that I try to show you here is required to prepare the shader to be runnable and to be available to our client program. So this C++ program is our client program. Of course, the shader is written in GLSL language, which is syntactically similar to C. And in our laboratory here, we have under Lab 2. In the shader subfolder, we have two of these shaders. You can open them if you'd like to take a look, right? So they're pretty simple. So the shader has to be compiled, and that's what we're going to continue doing in our programs. And these are examples of what it takes to compile and link them into the shader program. So eventually, when we are ready to use it, we have to issue a call to use the program, and I'll show you later on how is it combined with the geometry to draw and what happens at runtime when the shaders are ready and now we're ready to start actually displaying rendering the graphics. So the Vertex Shader is one of them right here. This is an example of the Vertex Shader. I'll keep everything visible. Okay, so and we need both of them, Fragment and Vertex Shader, to be able to make anything visible. And this is an example of what it could do with a cube that uses 8 vertices. Just a reminder that this Vertex Shader for a cube with these vertices will run for every triangle and every vertex that is present here. Okay, so Fragment Shader we'll also already discussed, and we said that it's the program right here that determines the final color of pixels on the screen, and in this example only the red component is set, and we display, eventually we will display something very simple on our screen. So it is a common practice to use multiple vertex and fragment shaders in a program. In this client program, we can have multiple different shaders that do things differently. So each shader is designated to work with different parts of the rendered scene. For instance, one shader can be responsible for drawing the sky, another one the terrain, and a number of shaders could be responsible for drawing buildings, cars, people, and everything else that you'd like to have in your scenery here. So let's get to the part here. Well, this is the next part of our work with this laboratory, is that the idea behind this lab is to actually create a helpful C++ class which will represent a compiled shader. So every time we need a new shader, we can just create an object and its constructor will do all of these steps and everything that these functions do to populate the shader and make it ready to be used in our program. So in our laboratory configuration that we downloaded, there is a source file, and notice there is shader.cpp. So we need to, this is the source file, which is the implementation file for a new class. We will call it shader, and this will be the implementation file that we will use to specify all the functionality. And the first step is that we need to add this file to our project as a source file. Notice the CPP extension here under source. So we're going to say View, Solution Explorer, and go to Source Files. Then right-click and say Add Existing Item. So Source Files, Add Existing Item, and point this to our source subfolder. And this is the file that we need to add to the source file. So just click shader.cpp and say Add. Don't add the .h file, don't add the header file. Header files should never be added to the list of source files. You'll get all sorts of strange errors if you do that. Make sure that you add the CPP file. Okay, so the next thing is, so I already have this shader CPP added. So notice that this shader.cpp also includes the header file that we also have part of our source. So we'll open this as well. I just drag and drop it here to open it. Okay. So, and this is the proposition for the new. So we're pretty much done with the Solution Explorer structure. There should be two files on this list, both have extension CPP, and now I can close this. And this is the proposed idea behind the shader class, is that when we create the shader, this is the constructor, it will take simply the path to the Vertex program on our system and to the Fragment program. And what it will do, it will load the text file, check everything, display errors, and link everything together and generate this program ID, which, if everything is okay, will make this object encapsulate this integer that represents a program ID. And now this program ID can be used elsewhere in our main driver like this to use it to render geometry on the screen. All right, so these are the things that we have. Next, what we're going to do is, in the source file, shader.cpp, actually I don't like the way it's being opened here. Let me go to View, Solution Explorer, just double click. I prefer all my tabs to be grouped like this. Okay. So here we have a constructor of this class, right? So this constructor is declared right here. This is just a declaration of the constructor, and this is its implementation, and this is how constructor implementation looks like in C++ implementation file. And we need to do some work over here. Basically, this is the most challenging part of this laboratory. So we'll have this shader shown side by side with the main file, and we will move the loading of the text files and then compiling everything, and we'll just put everything inside the constructor of our shader class. So I'm going to maximize this view, and I'm going to click my main program that we looked at to begin with, and just move it to a new vertical document group like this. And basically what we observed, what is happening here in our main function. Notice that this is our main function where the application starts. In this section we start working with the shaders, and we're just going to move this code over. So read the Vertex program file. It's this line of code. Right, this line of code loads text file. So I'm just going to cut and paste, right? So I can cut this line, Control X, and Control V. So that's the idea. Basically, this type of work we would like to encapsulate inside the constructor implementation. So next, read the fragment program file. Okay, so we'll just take fragment shader source equals load text file and move it right here. Okay, so we're doing this in stages. Check to make sure that neither of these are null. So basically what has to happen here is that if this function fails, or this function fails simply because the definitions of the Vertex Shader and Fragment Shader point to a non-existing file, these pointers to the text will come back as null pointers, because that's how load text file works. So I'll show you what we could do. I mean, we could do something like this. We just could check for the null pointers. So this is my example. For example, if this source happens to be null, then we print to the console error, and we display what that what is the actual Vertex file name was. So here I'll use we need to update, by the way, these two as well, right? So this is the Vertex file name, and this is the fragment file name. So this has to be replacing this, because these things were defined in our main program, and now we're changing all of this, right? So just make sure that you load text file, it's Vertex file name, load another one, it's fragment file name, which matches the input parameters of this constructor. Okay, so now we check for nulls, and we'll just print everything, and if something wrong, we'll just exit right away. So for now, that's fine. Let's see if this is okay. All right, so the next step is to make Vertex Shader, and of course it's called compile Vertex Shader. This is the actual function call that we want. So I'm just going to take this next line, Control X, and move it down here, right? So this is compile Vertex Shader, like this. Okay, so this is done. Then we make the Fragment Shader. It's the next line, compile Fragment Shader. Okay, so we'll move it down here, right? So it's compile Fragment Shader, and now we're using the source pointers to both as we are making this progress through all these stages, and then make the shader program and assign it to the program ID variable. So it's done by this line of code, which I will also take out of here, Control X, and move it to place over here. But I think that we're let's see if I move this to my next tab group. So this is the header file. So it's called program ID, right? So what we need to do is here just to replace this shader program ID, which used to be a variable in our main function. Now this is the member variable of our shader object, and so I will replace this simply by program ID, right? So this program ID is how we populate. And for debugging purposes, this implementation already printing that the shader ID is the program ID, right? So this is going to be displayed. And once we are all done, we are going to deallocate a memory which was allocated by load text file. So it dynamically allocates memory. So now it's a good idea to delete that memory and deallocate that memory, return it back to the system. So this is what we have to do in this part of the laboratory. So I'll try to make this visible. in its entirety. So this is my version of the shader constructor, and you can check in your version when you're completing this laboratory, just to make sure that everything matches on your side, just the way I did this.